So what makes protecting cloud applications so much more challenging than protecting traditional on-prem networks? Isn't it just a simple matter of the board or C-suite telling IT, look, we're launching a cloud initiative, now go migrate everything we have on-prem into the cloud? On its face, it would seem simple enough to just move the entire network infrastructure and the security stack to the cloud as is. We have Linux and Windows servers, routers, switches, and so on that we want to virtualize and move into the cloud to save money. And we want our end users to still be able to access the resources in the cloud from their endpoints, whether they're workstations or mobile devices, just like they did on-prem. And further, we want security in place that provides protection that is the equivalent of firewalls, endpoint protection agents, SD-WAN access management, and so on that are traditionally used on-prem. So where's the problem? The challenge is the cloud, its functionality, and its security needs are not just virtualized analogs to their on-prem counterparts. In reality, the cloud offers completely new functionality, such as direct internet access facilitating remote work, as well as global collaborative app development, project management, and file sharing. And to support this new functionality, the cloud must also maintain a more complex access model, where there is a new identity-defined perimeter with a profusion of identities and privileges, as well as new security requirements focused exclusively on users, permissions, access, and activity, versus ring-fencing servers, routers, and networks that was the primary focus for traditional on-prem security. All of this, from functionality to security, requires using completely new networking models and technologies. Let's take AWS for example. The concept of containers, for instance, is unique to the cloud, as are serverless frameworks, both of which don't lend themselves to the traditional cybersecurity paradigm. The advantages that these features provide pose real security challenges to DevOps teams. How can you protect something that's not physically there? Or take robotic processes. Security is inherently a speed bump in automation and the bane of high-velocity CI/CD processes. Or adaptable configurations. Changing configurations on the fly is a completely foreign concept in the traditional on-prem cybersecurity paradigm. DevOps teams find tremendous benefits in working in the cloud, such as real-time business intelligence and data analytics, where they're streaming and storing tons of data and calculating it very fast in real time. Cloud is also accelerating the development lifecycle process, where DevOps can spin up temporary environments in development, staging, QA, and so on, and then tear them down when no longer in use. All of this is actually saving time, effort, and money in the long run, because none of this is running on the expensive company-owned infrastructure, since the workload has been offloaded to the cloud and infrastructure maintenance to the cloud provider. Unfortunately, traditional cybersecurity teams, as well as many security vendors, just try to retrofit on-prem security notions and tools to secure the newfound functionality in the cloud. For instance, they think, maybe if we put a proxy in place, or deploy an agent, or set up some sort of jump server to bridge Active Directory, then we can build an effective cloud security stack. But the cloud ecosystem is much more complex than on-prem, especially when you consider that AWS alone has over 200 cloud services, and the usage model is fundamentally different, as users access and collaborate across multiple cloud services. Multiply that by the number of new SaaS, IaaS, and PaaS services being deployed daily, and there's absolutely no way to retrofit a traditional on-prem security solution that can satisfy the requirements of the new cloud reality. The good news is that a lot of these new cloud services support API integrations. The new generation of cloud-native API-based security solutions can therefore easily integrate with your operation-critical cloud services that DevOps is using and provide appropriate cloud security controls without disrupting CI/CD processes.